Buongiorno. I'm Ralph Lugon. I'm coming from the French part of Switzerland, and today I have to talk instead of Stephanie Rogers. I'm not Stephanie Rogers. I'm Ralph Lugon, who cannot participate to that congress. So the main job was done by Stephanie. So today I have the responsibility, in the name of the team, to speak about some result about that project. I wrote a title here. This was an experiment to try to combine glaciological and archaeological methods for gauging the archaeological potential in the Alps. The project was financed by the Swiss National Science Foundation and by the local government of the Canton of Valais, because in Switzerland we have a lot of different administrative regions. The cantonal region was interested by the conservation of objects that could be found in the high altitude level around glacier. So that was not only a scientific project, that was an applied project for the local government to begin a reflection about how can we prospect in high altitude level to try to find things around glacier that are now retreating very, very, very fast. So that was not a personal project, that was a team project with a lot of people working in it. I wrote some specialization here. We have two glaciologists from the Zurich University that are specialized in building modeling approach in glacier, because this is a highly changing environment and we have to take into account that parameters. We have Stephanie Rogers as an expert in spatial GIS analysis. She did her PhD work around that project. Of course, we have some archaeologists that were working in the field in the search of objects around the glacier, and we have a historian girl, Miriam, who worked in archival text analysis. So the study area, as everybody knows, Switzerland is located in the center of Europe, and the Valais region is located in southwestern Switzerland. Here, this is the study zone. So the Valais region here is one of the most glaciated part of the whole Alpine arc. We have the highest summit of the Alpine arc. About 40 summits are located above 4,000 meters above the sea level, with a mountain range here that we call the Pennine Alps, the localization between Italy and the Valais. Another mountain range here called the Berners Alps, and most of the people are living in the Rhone Valley, a huge glacial valley here. So the study zone that we have to focus on was located here on the international border between Italy and Switzerland. To approach this subject, we first did an historical analysis with analysis of text. The historian girl has to work in that region, in the Valais. You have an old map at the beginning of the 20th century with the glacier drawn in white here. So the important thing for us is that the historian has to analyze the credibility of the sources, because we have a lot of information about high altitude passes, but this work was done in the 18th and in the 19th century at a time where people have a romantic vision of the thing. So she has to search for the precise source to verify the credibility of that source, because we have a lot of information about the frequentation of high glaciated passes in the mountains, but we didn't know if it is very, very scientifically proved. The second work she has to make was to search in Sion, the main city in the region, in the archival government, to try to analyze the sources that are stuck in the archive from the 15th century to the Ancien Regime. And the idea was to identify some document, because when people travel around these high altitude passes, that was during period of crisis, when you have a rumor of war or rumor of epidemics or episodes, and that's generate document. And our hope was perhaps we can identify a document that indicate us a kind of lost passes and unknown passes where we have to try to search for artifacts. But the main results of this historical research was the following. First, we have an historical database that demonstrates the use of 10 high-altitude passes between 3,000 and 3,500 meters above sea level on glaciated area, currently glaciated, and we cannot find lost passes as we hoped before. This was not possible because the information in the archive was very general. We didn't have a precise geographical location, so that was not a success in that sense. Then Stephanie did a very important job in modeling approach with a geographical analysis approach. First, we try to combine this historical analysis with a least cost path analysis in that region to try to respond to the question, where could people have traveled in the past? Then we produce a locational analysis and then a glacier modeling approach because we want to identify where should ice melt the first or the fastest. And then we produce a kind of glacial archaeological potential map for the local government. Where should we look first to try to help the archaeologists to find artifacts in the mountains? So, we know this least cost path analysis used to calculate the easiest path based on geographic property of the terrain. We conducted several studies between archaeological significant locations in Switzerland and Italy, Sion to Domodossola and Domodossola to Sion, Aosta. That's the main place between the two mountain sides. We produce least cost path analysis between valleys on both sides of the border, and that was a preliminary step in the locational analysis. Here, a map just to show you more in detail the study zone. We have Sion here in the French part of Switzerland. Here, the Aosta Valley, the Antigorio Valley, and we produce a lot of least cost path analysis between those locations. But for me, the goal was not to verify the predictive capacity of the modeling approach. That was a participative approach. We were sitting together in a room with archaeologists, with glaciologists, with mountaineers, with people working in the mountains, and we together choose the weighting factors, the difficulty to access the mountain, and directly reproduce the simulation. For me, that was very interesting because I'm a guy from that region. I walk frequently in the mountain, and if you read a map, you didn't find all the things you can find with this least cost path analysis, because this least cost path analysis detect direction in the mountain that we don't have. We have not the idea before. For example, here we produce a least cost path analysis between Sion and Domodossola, and this is a zoom around the glacier, the Grand Désert glacier. The least cost path analysis from Switzerland to Italy is going that way, from Italy to Switzerland, and this path located on the crest ridge, we didn't know this region before. So the idea then was to go on that area and to search for good artifacts deposited on the glacier, because we have people, there is some woods deposited at 3,000 meters above this sea level. That was not free. You never had vegetation in that area. The only possibility is that human beings have left that woods in that area. So we make a C14 analysis, and then we discover that wood pieces dated from the Bronze Age, and that demonstrates the use of the past. So for us now, this area must be monitored very precisely every year to follow the retreat of the glacier, and perhaps in the near future we can perhaps find something artifact conserved in the glacier. That was for us a very useful tool. Then, how many time I have?
Plenty.
I mean,
think
I have enough time.
you just did 10 minutes, so you still have
10 minutes.
Yeah.
Thank you. So then we produced this locational analysis to try to forecast the location of sites based on the presence or absence of defined criteria. And we use this cost path. We try to calculate the distance from this cost path, the slope of the terrain, and we have a very interesting parameter from the glaciologists. We have the ice thickness measurements calculated by model. Then the calculation of the current situation of the glacier and the projection of the future of evolution of glacier was made for 50 glaciers in the Pennine Alps, and we calculate the retreat of the glacier every 10 years, up to until 2100, thanks to a modeling approach. And we use, the glaciologists use a high-resolution regional sky modeling, and this regional sky modeling was based on this glacier eye thickness distribution calculation and surface mass balance calculation, and we had the information about the geometry change of the glacier. Then this model of glacial dynamics takes into account climatological parameters like snow accumulation, solar radiation, and as an input we use a regional climate model from the ETH in Zurich. So a classic international panel of climatic change scenario. Then I'll show you here an example of a simulation around a very well-known past that was used during the modern time, during the Little Ice Age. We are here in the border between the valley and the Aosta region. The crest line here is located at about 3,400 meters above the sea level. You have the very well-known Cervin, Cervigno, Matterhorn here in that area. And here the Theodule Glacier located here. And during the Little Ice Age, there was a lot of trade exchanges between these two valleys. People used to go to cross the pass, and they have to walk about 2, 3, 4 kilometers on a very dangerous glacier, but that was not an obstacle for them. They go with mules. They have trade wine. Wine was imported from Italy to Switzerland, and there were a lot of exchange. So in that place, this is a place where the Cantonal Archaeological Service did a lot of survey, because it is a very important pass with great archaeological potential. Here, the simulation show with a spatial resolution of 25 meters, we can show the retreat of the glacier for example, in 2030, 2040, and so on. And based on that result, we can have an idea where we can prospect first, when we can wait for an archaeological prospecting. But as this picture shows, the retreat will be very, very fast, and we think that around 2050, the glacier surface we lost about 50% of its area, so a very high melting rate. Then, to go simply, this is a little bit more complex, we produce this kind of map for the Archaeological Service. This is a static map. The better would be to produce a dynamic map, because the model of glaciological retreat can be processed every year thanks to new climatological data. But just to show you an example in the same area, we are here in the Oberer Theodule Glacier with the 73 position of the glacier. That was the last cartography of Swiss glacier in Switzerland. And then here, the archaeological potential is indicated in red if you have the greatest chance to find artifacts, and in blue when you have the lowest chance to find something. Then here, thanks to the position of the glacier 2030-2060, we know that this highest potential here in that region will come in some decades, not now. Now we are going to make research here around that area, but we can wait some years to prospect in that region. That's the idea. Merci. So just some result very rapidly, because archaeologists made prospection during 4 years. I must recall you that it is a very difficult access zone. We are in a high altitude area on glaciated passes, and the time windows for the prospection is only 1, 2, 3 weeks in September. If you have fresh snow, you cannot find nothing at all. It's very difficult. So we try to have a set of data. A first set, we collect wood on the glacier surface or around the glacier. Sometimes we collect some bones, here mule bones, and at some places with a metal detector, archaeologists they try to detect shoe nails. Here, the set of paths that archaeology has prospected up to now. So you have in the red star the passes located between along the border of Italy and Swiss. Here, the very well-known Scideor Pass, that is one of the most well-known paths for glacial archaeology, because there was a lot of organic artifacts that were discovered here, but that was not in our project. So we prospect this high-altitude pass based on this cost path analysis and based on historical source analysis. So about 100 pieces of wood were collected, and with the radiocarbon analysis we identify about 20 pieces of wood from modern time, 7 Middle Age, 6 Roman time, and 4 prehistoric time. A majority of that wood were highly distorted by the glacial movement. That's the problem, because these woods are not artifacts. We don't know if they have been worked or not, because in the ice they can be conserved during thousands of years, but they are highly distorted due to the movement of ice. Perhaps there is some hypothesis, root markers, but we don't know. Here, just some results. The first result of the frequentation of high-altitude glaciated passes in the valley. First here, the col Cleuson, identified by historical sources. We have an indication of the presence of human beings at the Bronze Age. So this is a pass located at 3,500 meters above the sea level, not easy to access today. Here, the Theodule Glacier, with a lot of with some artifact that from the Roman period that was detected thanks to the historical source. Then the Col de la Forclaz here, with during the Roman period a kind of concentration of wood here that attests the frequentation of that pass at that time. Here, the Col d'Annibal, with a lot of wood discovered around that glacier that is located near the Grand Saint-Bernard, the currently pass used by automobile, but we are located in 3,000 meters above the sea level, and the Col Colon here detected thanks to the least cost pass analysis. So we have now this broad information about the presence of human being at a high altitude area. That this is a testimony that these high altitude passes were traveled by men. But now, for me, when I imagined that project, for me in the Alps there never was a systematic approach to try to help the archaeologists to try to define priority zone for the prospection. We had a lot of discovery, very prestigious, like Ötzi, the mummy of the Iceman, and the archaeologists concentrated on this mummy, but they didn't try to search on a larger area about the potential. And I think for my region, from the valley, this is very important to try now to systematize the prospection, because glaciers are rotating very fast. And with this first survey, the sample idea to collect wood on the surface of glacier, we have demonstrated that there is a potential of artifact discovery in the mountain area. And just some conclusion, 1 minute. But the performance of this model has to be tested in the field. This is a kind of virtual exercise, I must confess. Okay, we did a model, but we didn't know if it is efficient. The degree of prediction of such model, I don't want to enter in that discussion now, too short. The historical approach didn't give us the result we expected about the finding of forgotten paths in that region. But now archaeologists in the service have a greater understanding of the interaction between the terrain and where artifacts could be located. And the local government has decided to take those maps into account for future field prospection. What didn't make the model is that we concentrate our field work on huge glacier located at the border between Italy and Switzerland, but we don't know how to make for very small glacier ice patches that we have no sufficient resolution to detect the thousands and thousands of ice patches that are ice very static, located in permafrost zone, frozen to their bed, and you can have a very great potential of artifact finding in that area, but at the moment we didn't tackle that issue. Thank you.